Okay, so we're going to prove that if we have some function from any set A to the power sets of A, then this function f is not surjective. And again, we say assume there exists some f that is surjective. And what I immediately want to understand is I want to understand this set. So consider the following set. So let's define B to be a subset of A. So it's all the elements inside of A with f of x, with x contained in the subset that x is sent to under f. Okay, so this is the trickiest part about this part right here, because we want to get an idea of what B is. So let's take a simple set and then the power set. So let's say this is A. The power sets are going to be the empty set, the set of A, the set of just 1, the set of just 2, and then the whole set 1, 2. So I have A and then the power sets of A, and I have some function, I don't know, let's say something like this, right? You want to ask, what does B look like under this function here? So what's B in this case, right? So B in this case, right? Oh, all the x that are not contained in the subset that they're sent to. So 1 is 1 contained in the subset that it's sent to. So 1, is it contained or is it not contained in f of 1? Well, where does f of 1 go to? It goes to the empty set. So then this is the case. So then 1 is in B. So 1 is in this set B because 1 is not contained in the set that it's sent to. Now ask yourself, is 2 in B? Well, no, because 2 is sent. 2 is in the set that it's sent to. So in this case, we have it that B is just this subset right here. This is B, just the subset containing 1. Now, if we look at B, right, and we ask ourselves, right, consider B. Okay, we know that B is a subset of A. Since B is some subset of A, okay, and F is a surjection from A to all the subsets of A, there must end, let's say end, we're assuming F is surjective. So then that means, again, since we're assuming F is surjective, there must exist some little a contained in A with f of A equal to the subset B, right? You must have some, so we know that B, right, in the power sets of A, right, there's some subset B right here. It's a subset of A, right? So since it's a subset of A, there must exist some element over here, little a, that gets sent to B because we said that this function was surjective. So everything over here is going to get hit. So then now that we have that fact, right, with f of A equaling B, right, we know that there must be some A. We ask, is A contained in B? Okay, and this is what leads us to our contradiction, because we say A is contained in B. Well, A being contained in B means that A is contained in this set, which is here. Right? Or X, sorry, X. Okay, so A is one of these elements, but this means, right, this is B, right? A is contained in B, I just wrote it out, what B is. A being contained inside this set here means that A is not sent to f of A. So A is not contained inside f of A. But f of A we said was B, and we have A is not contained inside B. And this is clearly in contradiction. We just said A is in B, and now we said that A is not in B. So we have a contradiction. Now, what's the other alternative? So the other alternative is to say that A is not contained inside B. But then this immediately means that A is not contained inside f of A. And then this would mean that A is contained inside B, because that's the definition. Look, x, all the x not contained in f of x, this is A. A is not contained. If we say A is not contained in B, then A is not contained in f of A, because B is just f of A. And then that would mean that A is contained inside B, because that's the definition of what B is from here. And then this is a contradiction again. And those are the only two places for where A could be. And the whole thing is now in contradiction, and the assumption is false. So in either way, we get a contradiction. The assumption is false. F is not surjective.